Good day, everyone. As part of our discussion for fundamentals of thermodynamics and ideal gas, I will give you several example on how we could calculate the ideal gas problems. Number one problem is a mass of gas has a pressure of 500 kilopascal and a temperature of 150 degrees Celsius. If the pressure is changed to 900 kilopascal with no change in volume, determine the new temperature. So in the problem, it was stated that it means that the volume in state 1 is just equals to the volume in the state 2. Or it is a constant volume process. When it is a constant volume process, the problem can be calculated using Charles' law. But for this problem, we'll try to derive the formula for Charles' law using the ideal gas equation. But for now, we'll identify the given in the problem. In the state 1, the pressure is 500 kilopascal, the temperature is 150 degrees Celsius. In state 2, the pressure is 900 was increased to 900 kilopascal, and we are asked kung pila ang value sa imong temperature since nag-change man imong na-increase man imong pressure. So using the ideal gas equation, which is PV is equals to MRT, we could use this in calculating the problem. So according to the problem, volume is equals or constant. So V1 is equals to V2. Kasabot, ang volume sa state 1 is equals sa volume sa state 2 as what I mentioned earlier. So by rearranging the ideal gas equation, we could get the formula for the volume, which is equals to MRT over V. Substituting the value for the volume in our constant volume, so MR T1 is just equals to MR T2 over T2. And since this is a control system, so it means that the mass for the state 1 to the state 2 is just equals. So we could cancel the mass. And again, since the value for our R is constant all throughout the process, and it is a constant value in both sides, we could eliminate the last constant. So what we are left behind is T1 over P1 is equals to T2 over P2. This is the Charles' law. By rearranging the Charles' law, we could have the formula for the temperature, which is T1 T2 over T1. So we could use this to calculate the temperature 2 as what is asked in the problem. So T1, and the given for the T1 is 150 degrees Celsius. And since the unit for the temperature is in degrees Celsius, always remember that even using the ideal gas equation, always make sure that the temperature is in Kelvin. So we will add 273 para mahimo siya Kelvin. Ayan ang unit. So the value of pressure in state 2 is 900 kilopascal. Here, 900 kilopascal over P1. P1 is 500 kPa. So we could eliminate the unit for pressure. So magbiling kay ang Kelvin. So using your calculator, we could get the value of 150 plus 273 times 900 over 500. So ang value sa temperature is 761.4 Kelvin. So if you will convert this to degrees Celsius, you will just minus the 273. So naatay temperature na 488.4 degrees Celsius. 488.4 degrees Celsius. Let us proceed to number 2. So number 2, a mass of gas has a pressure of 1.2 megapascal and a volume of 0.03 cubic meter and a temperature of 100 degrees Celsius. If pressure is changed to 400 kilopascal and volume to 0.06 cubic meters, determine the new temperature. So, it is medyo similar siya itong previous na itong problem, which is ang number 1 na itong ipangita is ang temperature. However, in this problem, ang volume is hindi na siya constant, same with the pressure and the temperature. So, nag-vary na siya from state 1 to state 2, bali nag-change siya. So, dili na ta pwede mo gamit atong Charles law or katong Charles or the Boyle's law. So, what we'll use in this problem is we will just derive again an equation using the ideal gas equation. But for now, we'll just identify the given from state 1 and state 2. So, at state 1, P1 is equals to 1.2 megapascal, T1 is 100 degrees Celsius, and V1 is 0.02 cubic meters. At state 2, the pressure drops to 400 kilopascal, the volume is 0.06 cubic meters, and the temperature is muna siya itong pangitawad. So again, using the ideal gas equation, which is P is equals to MRT, we could calculate this problem. Since this is a control system, we could assume that the mass 1 is equals to mass 2. So it means that the mass from the state 1 is just equal from the mass 2, since it is a control system. From the ideal gas equation, we could derive the formula for mass, which is PV over RT. From this ideal gas equation, we could substitute this for mass, which will become P V1 V1 over R P1 is equals to P2 V2 over R P2. And again, since R or the gas constant is a constant value, we could just, and it is equal, we could just eliminate this from the equation. So our valence of equation is P1 V1 over T1 is equals to P2 V2 over T2. This is called the combined gas law. Combined gas law, or the general gas law equation. So from this, we could rearrange this to get the formula for T2, which will become T2 is equals to P2 V2 times T1 over T1 V1. T2 is equals to P2, the value for pressure in state 2 is 400 kilopascal. Then V2, the value of V2 is 0.06 cubic meters. And the value of T1 is 100 degrees Celsius. 100 degrees Celsius. And again, please take note that the unit of the temperature in state 1 is in degrees Celsius. We will use unit of Kelvin for when we use the ideal gas equation. So we will add 273 from the 100. So it will become Kelvin in unit over P1, which is the value is 1.2 megapascal. And remember, since our unit in the numerator for pressure is in kPa, it should be the same with the unit in the denominator. This 1.2 megapascal will become 1.2 times 10 to the 3 kPa. So please review also your metric prefixes. Then the value for V1 at state 1 is 0.03 cubic meters. We could cancel this out, cancel this, kPa. So what left in the equation is just a Kelvin, which is one siyang T2 is equals to using your calculator. 400 times 0.06 times 100 plus 273 over 1.2 times 10 to the 3 times 0.09. So we have 248.67 Kelvin. So this is our answer. Again, if we will convert this to degrees Celsius, we will just minus the 273. So we get a negative 24 degrees Celsius. Let us proceed for the final problem, for the last problem, which is the number 3. A vessel contains 0.2 cubic meters of methane at 60 degrees Celsius and 500 kilopascal pressure. Calculate the mass of methane. So not like the other problem, this problem doesn't undergo any process. So we could not use the Boyle's law and the Charles law, neither with the combined gas law. So what we will use in this problem is the universal gas law. But before proceeding to the solution, let us identify the given. So the volume is 0.2 cubic meters, the temperature is 60 degrees Celsius, and the pressure is 500 kilopascal. So again, we will just use the universal gas law. But let's see on how we could derive the universal gas law using the ideal gas law equation. So ideal gas law equation is equals to PV is equals to mRT. Since the gas in this problem is methane, assuming that we don't know the gas constant for this problem, for the methane, so we would use the universal gas law, wherein the gas constant is just equals to the universal gas constant over the molecular mass of the gas. So again, in our previous discussion, the value for the universal gas is equals to 8.314 joules mole Kelvin, or it just equals to 8,314 joules kilomole Kelvin. So in this, the value for the molecular mass, just a review from your chemistry, CHONS or CHONS, C for carbon, H for hydrogen, O for oxygen, N for nitrogen, and S for sulfur. So hydrogen, oxygen, nitrogen, and sulfur is a diatomic, meaning that they are bonded with 2 atoms. But in this, we will use their atomic weight so we could understand kung saan pagkuha ang iyahang molecular mass. So the chemical formula for methane is CH4. So the value of atomic weight for the carbon is 12. So we will have 12 here. Then the atomic weight of hydrogen is 1, which has 4 atoms. So multiply na to siya 4. So we will have a molecular mass sa methane is 16 kilograms per kilomole. So back here, makalculate na nato ang gas constant sa methane. So 8,314 joules kilomole Kelvin divided by what we have the molecular mass of methane is 16 kilograms per kilomole. So basically, ato na siyang gibuhat kay para makancel ang kilomole na unit. So cancel this. R will be just equals to 8,314 divided by 16. So we have 519.63 joules kilogram Kelvin. So back sa atong ideal gas equation, the universal gas equation, universal gas law is equals to PV is equals to M. Ang R is kani universal gas constant over T over the molecular mass. This is the universal gas law. This one is the ideal gas equation. By this, since in the problem, given man ang pressure, volume, and temperature, and we have also calculated already the gas constant for the methane, so basically what na ang nabilin is ang mass, which is mao siya itong makita. Mass is just equals to M is equals to P over RT. Mass is equals to, the pressure is 500 kPa, 500 kPa, so 500 times 10 to the 3. I've used this since ang unit na to sa atong R is joules, so atong ikuan dapat in Pascal siya. So just review your conversion of units, especially for the prefixes. For the volume is 0.2 cubic meters. The R is 519.63. And the temperature, again, since the temperature is here is in degrees Celsius, we will add 270 para may mo siyang Kelvin. So, by this, we could get a value of 500 times 10 to the 3 times 0.2 or 519.63 times 60 plus 270. We have a mass of 0.58 kilograms.